concept. So you should be attend, don't be absent for the concept, right? I'm going to explain first trigonometric, then we'll see inverse trigonometry, right? So sine x. Sine x is a trigonometric function. Then what is the domain? Domain and what is the range of the given functions? What is the domain of sine x? Anyone? What is the domain? Domain means remember that
All
x
real.
values. Yeah, real value. So what is the range? What is the max? A range in the sense,
Minus to minus
yeah,
1.
maximum value and minimum value is called the range. So maximum value is +1, minimum value is -1. So after this, we will see graphical representation of trigonometric. Then we'll see graphical representation of inverse trigonometric and principal value branch. Principal value branch, that is very important in inverse trigonometry. So what is the mean by principal value branch? And let us see everything. Okay, now so this is sin x and cos x. Already you studied what is the domain? Real. And here range -1 comma 1. Then what about tan x? Anyone? Tan x domain. Yes. Anyone? What is the what is the domain? Real number?
Root real.
Is it real number? Okay. If I take here tan 90, what is tan 90? Tan 90 will be
Chelsea.
undefined. Undefined or infinity here. Okay. Sin 90 by cos 90. Sin 90 is 1, 1 by cos 90 is 0. So 1 by 0, that is generally infinity. That is undefined. So then what about 270? What about minus 90? Minus 270? So for every 180 values, again, the value will be repeat. So whatever the tan 90 will be there, 270 also same. Maybe plus or minus. Undefined value. Tan 90, 270. Again, we can, for 270, you can add 180. Okay. So like that, 450. Then again you can add 180. For every 180, it will be undefined. So that here, from the real number, you have to remove 90, 270. Okay. So minus 90 minus 270 like that. So shall we write like this 2n plus 1 into pi by 2. Here n is belongs to z. Shall we write the domain like this? So other than this, like n is equal to 0, n is equal to 0 means 0 plus 1, 90 will get. I'm subtracting from real number, I'm removing this 90, and next put n is equal to 1, 3 pi by 2, nothing but 270. Not only that, n is equal to 0. If you substitute n is equal to -1, if you substitute -1 minus 90, substitute minus 2 minus 270 like that. So for every 90, 270, so on up to infinite. So n is belongs to z. It may be positive, it may be negative. So for these values, other than these values, the tan x is defined. Defined means we get a finite value. For this value, we get infinity. So whatever the value we are getting infinity, we can remove that. So what about the range here? Range. What
All
about the
real.
yeah, real numbers? Fine. Then what about cot x? In the same way, cot x also. What is cot 0? Cot 180. Okay, for all these values again it is
Defined.
undefined. Yes, r minus n pi such that n is belongs to z. Is it right? Now, so for every cot 0 is undefined, cot 180, 360, 547, 20. In the same way, you minus 180, minus 360, minus 7. For all these values, it is we get infinity. Other than that, we can remove these values from real number. For remaining all values, it will be defined and we'll get a finite value. So the output is, these are the input, then output is real numbers. You can remember that the range in nothing but that is the output. We are giving some input, that is domain. So in the same way, what about secant x? Secant x. Yes. Anyone?
So for
Secant,
tan x,
right, same r minus secant nothing but 1 by cos. 1 by cos. For what value of theta the cos will be again 0. So 1 by cos. 1 by cos means cos. So for x is equal to 90. X is equal to 90 again 0, 270 again 0, means something by 0 again undefined. So whatever we written for tan we have to write. So this is r minus some 2n plus 1 pi by 2 comma n belongs to z. Am I right here? So coming to the range, see secant and cosecant does not exist between minus 1 to 1, minus 1 to 1. So secant 0, we know that secant 0 1, secant 180 is minus 1. Am I right? So but whereas, so it should not lies between minus 1 to 1. So nothing but minus 1 comma 1. Other than this, the secant is exist for every real number. So that is output. In the same way, finally cosecant x, cosecant x. So that is like cosecant x means 1 by sine, nothing but here cot a cos by sine. Sine will become denominator. Here also same n pi such that n is belongs to z. So r minus same here also it will be does not lies between 1 to 1, doesn't lies between. Okay, so these are the domain and range. Domain and range, everyone should remember. Very important. If you understood this, then we can easily understood the inverse trigonometric functions. Right? Domain, range, domain and range. As a JE student, you must be remember this domain and range. So why we should take r minus n pi? This and all you must know. If we take, what will happen? Okay, so it will tends to infinity. So let us see then the graphical representation of each and every function here. Okay, first, to exist inverse of a function, I'm not discuss about trigonometric. Generally inverse of a function, when inverse of a function is exist, when the given function is 1 1 and on 2, then inverse exist. This is inverse is a 1 1 and on 2. Yes, every inverse function is always 1 1 and on 2. Okay, fine. Coming to trigonometric function, there are 6 trigonometric functions are there. Those uh, the trigonometric functions domain and range I have written here. Right. Let's coming to the graphical representation. Already we have seen in class 11. So once again, graphical representation. Look at here. First, I'm going to take sine x. Sine x means generally you can take a y is equal to sine x also. Y is equal to sine x. Right. See here, what is the domain I have taken for sine? Domain means x values. Range nothing but that is belongs to y axis. Okay, fine. So here, this is x axis. Yeah, this is y axis. Right. So the maximum value of sine is 1. The minimum value is minus 1. Here infinity. Here it is minus infinity. Right? Infinity and minus infinity. Fine. See, sine x domain is R. Generally, as we studied like sine 0, 30, uh, 45, 60, 90 like that. Here, try to take just 90, 180 and 270, so on. Then left side is same minus 90, minus 180, minus 270, so on up to minus infinite. Okay, y dash, here x dash. Fine. Since we know that, what about sine 0? Sine 0, it is 0 degree. Sine 0 value is 0. Okay, sine 90. What is sine 90? We know very well about the graphical representation. Anyhow, we can revise once the graphical representation. So, right. So, sine 90 is 1. Sine 180 again 0. Again 0. And sine 270 is clearly minus 1 and so on. So when we then what about sine minus 90? Since we know that sine of minus 90 can be written as sine of minus theta. Formula already we studied in trigonometry. So sine is an odd function, so that sine of minus theta is equal to minus sine theta. Sine of minus theta minus sine theta minus 1. Am I right? So sine minus 90 is minus 1, minus 1. Okay. So whatever the value we are getting, if we substitute this theta values, whatever the output we are getting, so we can take on y-axis. Like that is belongs to y value. I clearly written here x is equal to 0, 0, y value 0. X is equal to 90, sine 91, y value is 1, like that, y value is 1, y value 1. And x is equal to 180, sine 180 is 0, so y value is 0 again. So y is equal to 0 clearly lies on the x-axis. Okay, next, x is equal to 270, that is minus 1, I have taken here, right? So y value is minus 1. So now, then minus 180 here, it may be plus 180, it may be minus 180, sine 180 is 0. So in the same way, what about this? Already sine 270 minus 1, again minus is there, minus into minus plus 1. So intersecting all these points by a smooth curve, we are going to get like this. Yeah, we can extend like that. So we are going to get a sine wave. Okay, this is called sine wave. Fine. So this is the sine graphical representation of sine function. Okay, fine. So if we observe here, the maximum value is 1, the minimum value is minus 1. So the graph of sine x is lies between always minus 1 to plus 1. So minus 1, range is minus 1 to plus 1. It does not cross this borders, right? So minus 1 and plus 1. Okay, here the thing is, so already we studied about the vertical test and the horizontal test. I clearly explained in class 11. So where we can use that vertical line test, and in which case we can use horizontal line test. Can anyone say that? Yes. Vertical line test.
Vertical test for whether it is function or not.
Exactly. So now see here, sine x, we are saying that sine x is a function. You can draw the vertical lines from minus infinity to plus infinity. You can draw the infinite vertical lines. See, the vertical line, each and every line can intersect the given curve in the sine function. At most, how many points? You can draw anywhere,
One.
anywhere. At most at one point, then it is function. We can say it is function. It will be intersect more than one point. More than 1 point. It may be 2 point, 3 point. It is not a function. That we know very well. Then where we can use that horizontal line test? What is the use? Yes. To use horizontal line test to check the given function is 1 1 or not. 1 1 or not. Remember, student, okay, we can, this is very important, this can play very important role to find the graphical representation of inverse trigonometric function, horizontal line test. So to check whether the given function is 1 1 or not, so we can use horizontal, like you can draw the horizontal line, like I want to use horizontal line test. Okay, if I draw this line like x is equal to y is equal to 1 by 2, y is equal to 1 by 2. So that horizontal line can meet the given point at how many points? Yes. How many points? From minus infinity to plus infinity. Anyone? Infinite points. But what is the condition? So if we draw the horizontal line, it will meet at most 1 point only. Okay, if it is meet or intersect the given curve at most at 1 point, then we can say that that is 1 1. Is it 1 1? The horizontal line, this line, horizontal line can meet more than 1 point. So sine x is not 1 1. Sine x is not 1 1. If sine inverse is exist, then what is our condition? To exist inverse of a function, it must be 1 1 and all 2. So here itself we can say that it is not 1 1. Then here sine inverse is exist. But here Our topic is like inverse trigonometric functions. We have to discuss about inverse. Nothing but inverse is exist. But if you see that horizontal line, inverse does not exist. So what to do? Then what to do for to get inverse is exist? So you can make them given function into one by restriction, restrict to the domain, by restrict to the domain. So how to restrict, like, so for example, if I take that x values from, for example, here itself, I want to take like uh, like this x axis, y axis, here plus 1, here minus 1. I want to take just minus 92 plus 90, minus 92 plus 90 including 0. So I restricted that value from minus infinity to infinity. I have taken just domain. Here domain is R. Domain is R. But I restricted the domain minus infinity to infinity as just I am taking minus 92 plus 90 alone. If you understand this sine function, so we can easily understand the cos, okay, tan, secant, everything remaining all trigonometric five functions are becomes very easy to understand. So we can restrict to the domain from minus 90 to 90. Now we can draw the graph of sine x. What is sine 0? 0. What is sine 90? Plus 1. And this is plus 1. What about minus 90? Minus 1. So clearly it is x value is pi by 2. Output is 1. The input is minus 90. Output is minus 1. So your input is 0. Output also 0. Sine 0, 0. Sine 90 is 1. Sine 180 is minus 1. Now you can intersecting these points by a smooth curve. By a smooth curve, we are going to like that. Is it clear? This is the graph of the sin x from minus 90 to plus 90 alone. So what do you observe? This is the graph. Now you can apply the vertical line test. It is function. Now apply the horizontal line test. You can draw the any horizontal line. Y is equal to 0, y is equal to 0 0.1, 0 0.2, 0 0.3. So wherever you can draw the horizontal line, it will meet the given curve at most 1 point only. Then can we say that is it 1 1? Yes, the sin x is 1 1 from minus 92 plus 90. Okay, and is it onto? Yes, it is onto. For every, what is the mean by onto? So codomain is equal to range. Okay, so otherwise for every value of codomain, for every value of here codomain, there should be image in domain. Okay, so nothing but for each and every value of y, for each and every value of y, there exists a x value. For example, I'm taking y here, there is a x value. Y here, there is a x value. Not anywhere you can take, there exists some x value. For each and every value of y from minus 1 to plus 1, there exists a x value. Okay, there exists a x value, so that it is onto 1 1 as well as onto, then sine inverse is exist. Sine inverse is exist. I said that. Okay, so when what we restricted here, what is the domain I have taken in sine x? Anyone in that graph? Domain. What is the domain? Nothing but x values. From where to where I have taken? Minus 90 to plus 90. Yes or no? This is domain. What is the range? Nothing but output. What is the range? Cannot be changed. Range always from minus 1 to 1. Okay, fine. When I take the domain from minus 90 to plus 90, so we get the range is minus 1 to 1. This is sine x. Then what about sine inverse x? Sine inverse x. Just now I said inverse of a function, the domain becomes codomain, codomain becomes domain. So this minus 1 to 1 becomes domain. This minus 90 to plus 90 becomes codomain. Is it clear? So interchange. Right. So now coming to here, if we draw the graph of sine inverse, this is just sine x graph. So if coming to the sine inverse graph is a simple, so just change. What about the sine inverse I have written here? Sine inverse from where to where? Sine inverse x from where to where? Minus 1 comma 1 to and minus 90 to 90. Okay, then see, I said very clearly, domain always you should take on which axis? X axis or y axis? Domain always should lies on, yes, x axis. X axis we can take, so that is minus, sorry, this is 1 to minus 1. Okay, so 1 to minus 1 is the domain, and this range becomes okay, like here y values, so 90 to minus 90. Simply remember that x value becomes y value and y value becomes x value. That's it. Class ఉందా? ఇప్పుడు అయిపోతుంది. Okay, student. So right, so here when we see here, what about sine inverse of minus 1 becomes, that we know that minus 90. Minus 90, this is the point. So sine inverse 0 is 0 only. Sine inverse of this value is, so sine inverse of 1 is plus 90. Okay, sine inverse of minus 1 minus 90, sine inverse of 1 is plus 90. Now you can draw the graph like we are going to get like this. Okay, so this is the graphical representation of sine inverse x from minus 1 to 1 to minus 90 to 90. So then only, so whatever the branch is there, then this is called principal value branch. Principal value branch. Is it clear? Principal, you have to remember. You have to remember. So not only that, even in sine inverse, if I take here 92, 92, like 270. Okay, if I take only the domain from 90 to 270, what about this sine graph? This is also sine graph only from, but domain is changed. I'm taking minus 90 to 90, but here I want to take 90 to 270. Now, is it 1 1 by using horizontal line test? Yes, it is 1 1. Is it on to? Yes, it is on to as well as 1 1, right? So then the sine inverse exists from 90 to 270 also, like infinite intervals are there, minus 90 to 90. Okay, minus 90 to 90, and 90 to 270. Yeah, 272, like again plus 180. Okay, like that 450, like that. So not only that, even minus 90 to minus 270, minus 270 to minus 450. So like that, for each and every interval the sine inverse is existed, but the thing is, in all the intervals it's better to, you can take this minus 90 to 90, then this branch is called, okay, this branch is called principal value branch. Simply remember that, pvb. Pvb, right? Okay, so okay students, so we will discuss about graphical representation of cos inverse, tan inverse, so remaining all functions in fifth period. Is it clear? Shall we wind up the class?
Yes, sir.
Sir, next